with our LeetCode top interview 150. We have now done 30 of 150. 1/5, but it feels like it's taken such a long time. Okay, next one, still sliding window. Longest substring without repeating characters. Let's do Python 3. Okay, so I'm on my laptop, so this is a much smaller screen. Let's see if we can make it work. Given the string, find the length of the longest substring without repeating characters. Okay, substring, so definition here, contiguous non-empty subsequence. Okay, so it has to be like this part or that part in comparison to the subsequence we did last time, which could be separate characters within the string. Doesn't have to be continuous. Okay, longest substring without repeating characters. So when we look at this, you look at, okay, A, no repeating character, B, AB, ABC, still good. ABCA, that's a repeating character of A. So we could either take ABC, which has length 3, or BCA, which has length 3. Then we have B, again, repeating, then that's repeating. Okay. What about this one? We have 2. Now that's repeating. Now we have 3. Okay. So how would we solve this with this sliding window? Let's see. Let's look at example 1 and 3. Okay, so we are here. We have P, W, no repeating characters, length 2. Now next time we see 1 repeating character. Now what do we do? So in this case, we have ABC and the repeating character is A, so we can start after the last A. And then we have B, we can start after the last B. Then we have C, but that's just the same pattern. And now we have B. Okay, so this is where it's interesting. A, B, C, B. So we will have to start after the last B, which gives us length 2. So when we are here, A, B, C, B, we already have length 3. And then we can start with the CB because we cannot take the first B. Okay, so CB. And then we have B again. So we have to start off the last B, that just gives 1. Okay, so back here we had PW, then another W, so in this case we have to start off the first W, so there won't be repetitive W's. WKE, all good. Now here we have 1 more, so we have to take this. I think that's my solution. It would be good to see more examples because there might be other cases. Okay, let's code that, and then if it doesn't work, we will run into wrong answers with other examples and we can fix them. Okay, so as this is a string, we want to return the longest, the length, just the length. Okay, so let's say result. Let's start with 1, no, start with 0. We have a sliding window. We have 2 pointers for this sliding window. Usually sliding windows have 2 pointers, but this time we need to know if the letter I'm pointing at right now is already in this previous substring that I'm looking at. Okay, so we have this, and now we run into another A. How can we know? Okay, A is already in there, and hopefully this takes constant time. We do not want to go traverse that substring to see if A is in there. We want some kind of way to just check A is in there constant time. So I'm thinking dictionary, but maybe a frequency array could also work. Let's see. What if we had a frequency array for letters? What do we have as input? Letters, digits, symbols, and spaces. So we not only English letters, so we need all those. All those characters. Let's see. Table. So we have 128. What do you have here? No. Space is there, and then numbers, letters, symbols. Okay, so 128. What if we have this frequency array that's okay? So in Python 3, how do we initiate an array with 128 size? Can we do something like, can we initiate with 0? Actually, I really do not know if this works. Okay, so this is what we want. Default value and size. Okay, let's try that. 0. So that's the letter frequency array. So what if when we see a letter, we increase that frequency to 1, and after this we should have ABC all at 1, and next time we check if that is already 1, then we know that is repetitive. Oh, I see. Now we actually need one more thing, which is the index of each of those letters. Because once we find, okay, A is repeated, we need to know where that index is so we can start from the next one. So we need to store that as well. Could we store it in here, or do we need a dictionary? Okay, let's try the dictionary instead. Let's letters dictionary. Let's initiate the dictionary, and then when we see anything, we put that in the dictionary. When it's already there, we know in constant time, and we can store the index as the value and the letter as key. Okay, so letter, no, it's not letters, it's gonna be all kinds of characters. Let's just name it dictionary then. Oh, I forgot to start the timer. Okay. Now we don't know how long it's been, so surprise. Alright, so now let's go through the string for each character in the string. What do we want to do? If this character is not in the dictionary, then we want to put this in the dictionary and have, we need the index for this. So that's the index. In range length of S. So if it's not in the dictionary, then we put in the dictionary and set its index as value. If it's already in the dictionary, then okay. Okay, so once we find a repeating character, that's when we calculate what's the length so far, I guess. Okay, so how about we have a start index? Let's start from 0. So now we have found a repeating character. Result is current index minus start. So we're at 3, start is 0. Okay, so we update our result and we need to update the start index to be the next of start index would be +1. Okay, so that's what I'm thinking. What else? Return result. I'm pretty sure it's missing something, but let's just have a look first. Okay, let's have a look at the first example. So we start from this. When we're at index 3, we have this result update to be 3. Start is not 1. Oh wait, we are missing something. So now this A is no longer at the last index. We have to update the index of this new A. Okay, that's missing. Very important. And this is repetitive, so we can refactor that. So this seems to be working. Let's see if this logic works, then we can do refactoring. Okay, let's see. Empty 0, 1. So we have just one space. It is not in the dictionary. We put that in the dictionary, okay? Do you want to have this update like this? And we always want to put this in. Wrong answer. Oh, I see. Yeah, so this start has been updated after that, so that's not gonna be the same start. Result, we have it up there, then we are not updating. Oh. Well, unless the string is okay, if the string is empty, then we have 0, but otherwise it's at least 1. Seems like I'm still missing something. Start. Salt. Okay, a little factoring first. So this is not gonna be correct. We still have this. So it starts at 0. If we only have one character, this will be 0, and this will give us 0, whereas that 1 should give us 1. So how do we fix that without adding some special condition there? Okay, let's just see if this is what's missing first, because otherwise there might be other elements missing in this. Okay, AU 1 2. Okay, Alright, let's see. AU. So 0, 1. Okay, so we need to fix when I is at the last index. So I first is 0, then I is at 1. Okay, I is at 1. Mm, 0, 1, 2. So what happens here? It's a 3. So this would not be correct. So this would only be if C is not in dictionary. If C is not in the dictionary, there's a few ways to, okay. So, okay, if C is in the dictionary, then we want to do this. If it's not in the dictionary, then okay, so this definitely needs, yeah, this needs adjusting. Okay, TMM, expected 5. This is the expected. Still need to fix this last index thing. So we are at index, let's say 6. That's the last one. Let's see index 6. Oh wait, so what happens here? We have TM, then we have M. So actually, when we start with this, we have to remove everything that's before that M as well, not just that M. Because we're starting a new substring now from this. So I actually need to remove everything that's before, which this is a point that we missed before. That adds another layer of complexity. So we need to remove that. can we do that without going over all the values in the dictionary? So all the indices, they are stored as dictionary values, and once we find the repeating character, we want to kind of remove all the characters that has indices before that one. That would not be a constant time operation. How can we do that? Very interesting. So I'm thinking that we could potentially have another dictionary, but it just seems like it's not a smart solution. So current dictionary is key being the character and value being the indices. What if we have another dictionary? Well, okay, we don't need another dictionary because when we have the index of that one, that's 1, we know that we want to remove in this dictionary all those characters that are before that index 1. We could just go over everything from start until before that index and remove all the letters between. I guess that's what we have to do. There's really no other way. We just have to imagine if there were 5 different letters there. I mean, we would remove all 5. Is that what we do then? Okay, let's write that. So each time we see a repeating character, we need to refactor this as well. So remove that. So if it is not in the dictionary, then I minus start plus 1. Okay. Otherwise, if it is in the dictionary, then so this is repetitive because in the last round, when it's not in the dictionary, we have already updated that. So I feel like this is repetitive. otherwise, okay, we are updating the start to be after the last character. Okay, what else do we need to do? So before we update that, we wanna arrange everything from start until so dict C, that will be the index of the last character that's not being repeated. And we want to remove everything from start until that. That will be +1. So everything in between, we want to remove them from the dictionary. Let's put from dictionary, remove key, value pair. Okay, delete. So I'm gonna delete that key value pair for all of those. Okay, and then we update the start, and lastly, for each round, we are updating current index for current character. Okay, let's see if that works. Oh, I see. Okay, so that has to be, so SJ would be that character. J is just the index. Key error A. Oh wait, so this is the current. The current index is I. Last index is dict C. So if we are looking at this one, if say we are at here, and that case start will be here, index 1, we are at index 4. So I is 4, so we want to remove everything that's here. So start until dict C, that is 1, plus 1 or 2, so start is 1, 1 until 1, so that should be correct. Why isn't it correct? Start. see which example it is. A was not able to delete A. I is at A, J is 0. Why isn't this working? SJ, this looks correct. Okay. Oh, okay, it's now, look, it's here. Start is dict C, Oh, I see, because dict C has not been deleted. Okay, let's see if this logic works. P 2 0, then W 2 1. Okay. Why is this returning 2? Zero, not in dictionary, put in the dictionary 001, and W 1012, so result is currently at 2. Dictionary has these 2 letters. Third one, we are here, it is in the dictionary, so from start 0 until that will be 1, so 1 and 2, we will delete these, and then we want to put this in the dictionary So that is at dict W would be 2, and start would be start has to be but start should be okay. So I need to first register that start. Okay. Still not correct. Let's see. Why is it not printing anything? Console. Okay. MTEXT. Well, it seems like I cannot print anything to console, so we will have to just overview like this. Alright then, so T, M, they will be in the dictionary. Now we're at index 1, I is 1, that is in the dictionary. So start will now be, okay, I is 2, start will now be 2, because that gives 1, so start is 2, which is correct. Now for, we need the last start. So this cannot be before. Tricky. It seems like the order here needs to be switched depending on different cases. So cannot put that start there. Okay, so we need the last start. We need to remove everything from the last start until current. Repeated letter, and then the start will not be current DC. Okay. Okay, so let's not remove current, this repeated letter. Let's only remove everything before that, because we still need its index. And then we just update the index to the new one. Okay, let's try that. Alright. I don't know how long it's been. I'm not on my usual. Oh wow, at least that worked. Alright, that seems to work. So let's remove our print and see if it's efficient, and then let's refactor, because apparently we are doing this. Alright, let's see. Okay, much better, much more efficient. Let's see if we can refactor some more. Result dictionary start 0 for I. Have this. C is the current character. If it's not in the dictionary, then we update result. We increment. So we do the incrementing and we also do the maximize. If it's not as long as the longest substring, then we just increment, and this will still be the longest. If it is in the dictionary, once we find a repeating character, we want to remove everything that's before that character. We want to update our start to be the character after the last repeated character. And then we want to update our current index for this current character. Okay, that seems to be as compact as it goes. Oh, alright, that's very good. Runtime. Okay, no follow-up questions. Alright, I am happy with the solution. It seems to be as compact as it goes. Let's do time and space complexity analysis. I don't know how long it's been, so apologize if this video is super long. I don't have a clock. Now I'm just on my laptop, I can't really see the clock. Okay, time-wise, we do have 2 for loops, but since it's sliding window, let's see, we are sliding this window. Once we find a repeating character, that's when we go into the other for loop. So let's say we're sliding the window like this, and then we see a repeating character. Let's say it's somewhere in the middle, then we need to remove the front part of that sliding window. So what would the time complexity be? Okay, let's think this way. So we are using this sliding window. This window is going to expand towards the right, and then it can shrink from the left side. So for each letter in this input, it can at most be expanded once and be excluded once. So each character here, it's either in the window or not in the window. When it gets included in the window, that's once. Then further down the road, it might get excluded from the window, or it might stay in that window until the end. So So at most it could be included and then excluded. So that would be at most twice. So that would be linear time, because each input in this input array will be looked at most twice. So even though we have two for loops, which looks like it might be quadratic, it's actually still linear. That's why this algorithm is efficient. So linear time and the linear space, because we're using a dictionary. Extra data structure that could store potentially the entire input. So linear time, linear space, that's still pretty good. And I don't know if we can optimize even more in this case. We always need linear time to scan the input. Could we possibly do constant space? I don't think so. So this should be optimal linear time and space. And I don't think I can refactor more. This looks pretty compact to me. Alright, so that's my solution. Let's have a quick look at top solutions. Sort by most votes. That's exactly the same idea, same approach. Okay, so for if it's in the dictionary, oh, I see, it looks like it's not doing this deletion part. Interesting. Let's see. If it's in the dictionary, J. J is map get +1. J. I guess J is the put I. Is J the start or I'm not understanding this J. Wow. Also Q. Okay. Okay, let's go back to this. We have a dictionary, I and J. So I should be the same I as my. J, if map contains current character. If current character in the dictionary, then we do this. Maximum of J, or the last index last one. I mean, I get that's putting the start to that, but why is it using maximum of that? And then this, and then this. So there is no deletion of the dictionary. Why is that? So is it not necessary to remove those from the dictionary? Okay, so this is more in line with what I'm doing. They're removing it from the set. I'm really curious why this works without removing it. Okay, let me think about this for 2 more minutes before we move on to other solutions. think I got it. Okay, I think I got it. So this would take care of, this basically takes care of the deletion because, okay, I wish we had a concrete example, but I think, so we did run into an example earlier, and that's why we even wrote this deletion part. So that is taking care of the case when, okay, we run into a repeated character. Okay, all good. We want to set the start to be after that. And the case is the part before that repeated character. Let's say that there is a T before that part. And then after that repeated character, there is no T. So we wanted to delete the part that has the T because next time we see a T, it is actually no longer in that substring, so we could actually just include that T and go forward. But if we don't delete that, it would appear as if, oh, we already have a T, even though our start index is actually after that T. That's why we even wrote this deletion part to start with. But what this would do is that next time we see that T, we see, okay, so that is already in the dictionary. So it is in the dictionary, but it's before that start index. So the J here, so this J is the same as our start. So the start index is actually after the index of that T, which would be this part. So in that case, we do not want to set the start to be the last index of T, then +1, because that is to the left of the actual start we are having. So in that case, we just keep our start because we have already, it's as if we have removed the previous parts. So this new T that is already in the dictionary, it still works because we no longer consider that part before the start. And we will continue to update the index of that T in that dictionary. Okay, I think I got it. Very smart. I'm not sure how to come up with that, but it's very smart indeed. Alright, okay. I think, okay, let's look at one more with Python 3. Not in the dictionary, okay, just like mine. If it is in the dictionary, So this is the case where that T is actually to the left of our start index. Yep. If it's not, then we set our start to be this. If it is, then we're still keeping that start index, and it wants to update this again, update result again. Alright, okay. I wonder how long this video is, I don't even know. Alright, well, that's it for this problem. Very interesting, very worthwhile. If this video is super long, I will make another one just to explain the algorithm. I will see you in the next one.